Hello, my fellow YouTubers. It's Roy back again. Hello, Anthony. All right, let's start off. We're going to work through this. There's the Bendini wheel setup. Using that is my primary, it's a bifiler. Going into my 2N3055. Ben. Ben. Benny. Say hi to everybody. Hello. Mr. Vincenzo is right there. There's Vinny. So we got the Bendini wheel. Got tachometer for speed of the Bendini. Got the resistor, variable resistor 1K. Will control the speed, which controls the frequency, which goes in the Figuera generator. And we're charging 3 batteries, and we're using 24 volts. Yeah, to turn off my speaker, realize it makes it sound pretty crappy. Yeah, go ahead, Justin. Fire in the hole with the question. Yeah, cutting lines of force. So, now that you bring up cutting lines of force, well, it's compression strokes. No, compression strokes would be different, because cutting lines of force is what this pickup is doing. Because the coils are wound around the cores, the action between this being a south pole at the bottom and this coil being a north pole at the top, there's a reaction, and the pressure that you speak about is the fact that we're pulsing this array, and every time we pulse it, we're adding resistance to bring the pressure down. So it goes from full to low, but we're also creating a wave. That's why the north is, or the negative is connected on that side. That would be the south, that would be the positive, so it travels. Then you see the opposite where the north is connected here and the south is there, so you can see how it travels. So it kind of has a flash about it. Let's go ahead and start off with the wheel. So basically this is going to be our frequency. And I got this down low. Hey Dave, greetings. So I got the speed down low. There's no resistance on the setup here for the Bendini. This itself here is going to be the frequency. Now I calculated the Schumann into how many revolutions this wheel needs to turn. And we need to be around 3,700 plus turns. And you can see that we are at 2,100 turns. I haven't accomplished 3,700 turns yet. Let's let that speed get to its mature speed, and then we'll make some adjustments. You can hear that wheel turning. Now I'm going to go ahead, and you'll notice that right here there's a little light. Well, I'm going to show you cut lines of force right here. What we're going to do is this is hooked up off the back EMF of this wheel right now. So the energy that's coming into this is a linear motor. And this linear motor is going to make a electromagnetic wave, like a sine wave. And the only way it can do it is if I take this positive and run it across the resistance. When I run it across the resistance, we'll see the voltage show up here. And this voltage here, for instance, I'll go ahead and do this now. So keep your eye on that voltmeter. That's connected to the pickup. This right here is the pickup. These are cutting the lines of force. These coils are cutting the lines of force in between a moving magnetic field. So now we're going to, there's nothing on the voltmeter, but we're going to move the magnetic field. Now, one thing I want you to know, this ain't spikes. This is true accurate, because I got that voltmeter is coming off a full wave bridge rectifier. As we're coming out, we're going into this full wave in AC, which is what this is getting, but we're coming out of it as DC. So the diodes there will correct that and make it into DC. So now we're going to go ahead and brush this. Look at the volts. They're just volts. Now, watch, I got it set for 600 volts. Now what we're going to do is, we've got the resistance a little tight right here. So it means the resistance is from here to here. So it's probably 5, 10, about 15, 18 ohms. Now watch what happens when I brush. Watch the voltmeter. Look at that, 300 volts. It'll say, when it says OL, that means it's over 600. Now what I'm doing is I'm putting a pressure wave into the top and bottom. And when I come closer to one side, means that the high side is over here. When I come closer to the other part of the wire, that means that the high side is down here. So there's a fluctuation. So we're banging this up and down. But we can get this volts up here to be in the 400 or 500 range. And that's by varying the moving electromagnetic wave that we're creating. So watch this. So I'm going to go ahead and I'm going to show you how speed really matters. So right now we're at 2400, 2500 RPMs. And we're climbing. So let's do that again. Did we put a load on this? Let's look at that odometer as we do this. You can see the volts showing up over here. Let's look at that. The volts are showing up, and the odometer is doing what? It's dropping down, so we're putting a load on it. Ha. Look at that. So the wheel slowed down by putting a load on it with this. There you go, power in, power out. So let's go ahead and add more resistance. And you'll see this light right here get brighter. I'm going to go all the way up right now. See the lights brighter. We added the 1K resistance. The speed jumped up to 3,200 RPMs, and it's climbing. We're going to work through this because you can see that the load I just added. What's going on, Adam, in the house? Now, to get this into the speed of the Schumann resonance, this is going to have to be at 3,700 RPMs, and I can't get there yet. A lot of threes. Let's go ahead and swipe this across here and see if we're going to put a load. See if it drops down. We can see the volts go up over here. All right, so I see the voltmeter going up pretty good, and I don't see the speed dropping down. So that's where I think there's a reference. This is how you brush across, but you'd have to go back the opposite way in order, because what we're doing is when I swipe that, we're creating an electromagnetic field right here, and we're creating a sine wave. So I'm going to bring in the resistance closer. That was about 70 ohms total. And now you'll see the speed, the tachometer, and then we're going to put a load on here and create a wave over here. Through the pickup right there, this voltmeter coming out of a full wave bridge rectifier will give us DC volts. So let's go ahead and look at that, 200 and something. So you can see, and we can also check the odometer. Well, the odometer doesn't seem to be having issues. And look at the volts jumping up and the